many of these machines aren't something that a person has to stand and push a button for every time the metal stamping machine needs to stamp a piece of metal. But they're also not yet set up to be able to be run remotely and automated.
Welcome to Coffee with Mr. IoT, a weekly chat with Robert Schmidt, Deloitte's chief futurist, and the builders, dreamers, founders, and wild children of the IoT universe. This podcast can also be viewed on the Coffee with Mr. IoT YouTube channel.
Hello, my name is Robert Schmidt, also known as Mr. IoT. I am Deloitte's chief futurist, also the host of our show Coffee with Mr. IoT. And today I want to welcome my guest, Ed Kasimchuk. He's the CTO of Software Design Solutions and also the founder, actually. And so let's start with welcome, Ed. And how did I do in your last name? We practiced it before a little bit, the second syllable. I remember that.
Terrific, Robert. Thank you for having me on.
It's great to have you. Ed, tell us a little bit about yourself. Tell us about what Software Solutions is about and what you're passionate about.
Sure. I've been in this business for a little over 32, 33 years now. And, it's started as a lot of embedded work, did some things with Raytheon and Texas Instruments. And so I got into DSPs and tools and all of those things. But as things started to, come into light that IoT and before that machine to machine was an important part of this industrial industry, that's where we started to focus. And so for the last 10 years at least, Software Design Solutions has been focused on IoT long before it was called IoT, when it was just machine to machine and industrial control and those types of things. More recently, we were acquired and Software Design Solutions was acquired by the same owner of another company, Applied Visions, and they're a cloud, mobile, enterprise level application. So when we put the two companies together, one that is focused on embedded systems and sensors and low power and edge nodes, and another that's focused on cloud applications and mobile applications, we thought that combination was a good combination to bring together to be able to put more effort in that direction.
So Ed, for you, someone who's been in the business for 30 years, you got to be laughing about this whole IoT hype. But I'm curious, how much are you laughing? How much are you happy that it actually finally came to fruition? And why now?
It's interesting. I've had a couple of conversations about the why now. First of all, the laughing part. You and I have been in this business a while, so you were around with .NET 2.0. And that was, a huge thing. But now when you look back, you can't really bookend what year started .NET 2.0 and did .NET 2.0 ever end, and was there a 3.0? I don't know. And IoT is very similar. IoT is a name for something that was always needed. And it's a name for something that now, with the convergence of a couple of interesting technologies, has a lot more impact than it could before. And what I mean by that is, when you start having the ability to put low cost sensors on all kinds of equipment, all kinds of places. I mean, we could have had the Internet of Things 30 years ago, but the problem is we just couldn't afford to put that kind of processing power out at the edge 30 years ago, because the kind of processing power that it took would have cost $1,000. Now for, $8, $10, we can put a pretty hefty processing node out at the edge. For $25, we can put one with cellular capability out at the edge. And so now that convergence, plus on top of that, the low cost communications with NB-IoT, Cat M1, those kinds of things have opportunity now to have this low cost, pervasive communications to edge nodes. And I think that even without the hype, even without the name, I think that would have gotten us IoT.
So technology-wise, much more processing power, cheap communication, and putting stuff at the edge that we couldn't put there. Let's talk a little bit about the edge or fog, or what's the difference to you? I actually personally use them interchangeably, and I never quite know what to call what. Personally, I like fog better because it sort of feels a little further away. Edge is sort of anything.
Mhm.
Today, I found people putting computers out there and call it the edge, which to me, that really isn't true. But in any case, what do you think? What's fog? What's edge? And tell us a particularly exciting use case that you've seen.
So I think that like a lot of definitions, it depends on who you're talking to and what they're trying to sell. And so I think that the folks that are trying to sell hardware like to say that they're out at the edge, because when you look at, the number of IoT devices, it's a triangle, right? That up at the top, there's kind of one cloud, and then in the middle, there's maybe tens or a few hundred gateways, but then down at the bottom of the triangle of this, food pyramid of devices is just thousands and thousands and thousands of edge devices. And so when people talk about the edge, I like to think of the edge personally, when I define it, as something that is directly connected to what it's sensing. And to me, that's the sensor, right? And to me, edge devices are generally pretty dumb. They're generally low cost.
And
They
small.
have to be very, very, I would say, able to stand a harsh environment, robust. And so, to say that I'm going to put, an industrial PC and call it an edge node, or, a Raspberry Pi and call it an edge node, it's not quite. And the lines get blurry. The lines get really blurry, because
So when do you call it fog?
So what I call fog is the first level up from that, where you have, the things I tend to define it as, you have AC power, first of all, so that now I can have lots of compute. Because we live in a world at SDS where we're constantly worried about battery life and power consumption, because we do a lot of low power sensor design, low power prototypes for new technologies for customers. And at that first level where you start to have, where you can plug in a wall, both for AC power and for internet accessibility, that first point is where I call the fog. And what I can do there now is I can have, quad core x86 with a couple of GPUs, and I can do interesting machine learning. Not that it can't do it down at the edge. There's lots of edge machine learning that says there's happening. But the reality is I just don't have the horsepower down at the edge. And if I do, I don't have the battery life to run that horsepower for very long, especially in our target industries, which is mostly industrial.
Give me an example where you used both edge and fog.
Sure.
To me, I hear you, right? Edge is really might be close to my skin, or really on the machine.
That's right.
It's really with a sensor. And what
Right.
you said is it's dumb, and it's really kind of meant to just sensor, take the data, maybe filter it, but then send it on to
Right.
what you call a fog device, and other people would like to call it a gateway. I do love your definition of fog. So give me a good example. Industrial, I love industrial, where you have edge, fog, and then cloud.
That's great. So let's talk industrial then. Let's talk a industrial plant with a couple dozen or a few hundred machines, and each one of them might have a couple of sensors, maybe a temperature sensor, maybe a vibration sensor, and those two together can get you an awful lot of predictive analytics in terms of maintenance and those types of things on those machines. So now at the edge, those sensors first of all, they have to be relatively cheap, because you might have to disperse a few hundred of them throughout your plant. They also have to be very, very robust. They might have to live in a world with temperature, and they might have to be washed down with a pressure washer, and they might have all kinds of harsh environment to live in. But they do have to do some processing. They might do simple averaging of the values that they read, because you can't take, you might be sensing, the temperature every second. But you don't want to send 86,400 seconds worth of readings all the way up to the cloud, or else you're going to fall over when you get your cellular bill if you're sending them cellular. So that sensor could do some interesting processing. It could do some averaging, keeping around lows and highs and interesting data with very little horsepower required. That can run on a coin cell. Then at the next level, you have the ability to do a couple interesting things in the fog, because that fog gateway computer now can look at that temperature sensor And it can have information about, well, what did that temperature sensor, how does that temperature sensor relate to the vibration sensor that is on the same piece of machinery? So now at that fog, you can start to do interesting machine learning type applications where you're looking at the correlations between temperature and vibration. You might be looking at temperature and vibration and time of day, or the job that you're doing, and potentially if this is a metal stamping machine, this type of job might cause more vibration than a different type of job just by the thickness of the metal you're stamping. But you can know that at the gateway level. Now, the reason why you don't just stop there, why you bother sending stuff up all the way up to the cloud, is that so that up at the cloud now you have really as much storage and bandwidth that you want to pay for. And it's pretty cheap up there. So now you can start to look at that same machine and say, well, how did it compare to last year? How did it compare to the machine in a different state? Or how did it compare to the vendor's own published data about this machine? And you can start to do other interesting higher level machine learning, and you can start to have things like dashboards where you can have a nice pretty map of the whole United States, and here's how all my machines are performing. And you can start to say, oh, look, we have somehow we're getting more potentially more breakdowns at this plant. What's going on? Is it because of fluctuations in temperature at that plant? Maybe they don't like being run, when the outside temperature is 95 degrees and the inside temperature gets to 110 inside that plant. So maybe we ought to invest in some air conditioning or something like that. So I think that each level has its job to do, and it's a kind of a data decimation activity going upwards, because you can't just flood all the data to the cloud. And it's an intelligence activity going downwards, because based on those things that you find out at the cloud, you may push down to the gateway or push down to the sensor different configurations. So you could say, look, we don't have to sense temperature every second because it just doesn't matter. Every 5 minutes is good because this is a big piece of metal and it doesn't change temperature that often.
I gotta say, for you and me, I don't know, I love these conversations, right? This is like pros and cons, and you debate. It's like a huge puzzle, and I love big puzzles, and that's, I think, why I'm in tech, right? I love putting the puzzle together to solve problems. But it's also complicated. Do you think we're gonna get to a place where actually the AI or the ML is gonna decide where to put stuff, and it's just gonna say, hang on, I got all this data, I'm not using it at the edge, let's stop there, or no, please send it more up to the cloud, and they just talk to each other and I don't have to think about this anymore?
I think for a long time, AI and ML is going to be a tool. And I think that when we talk with C-levels, C-level folks, and they're talking about how do I get started with these kinds of projects. The one person that we tell them they cannot leave out is the domain expert at their company that already knows all the interesting things. I think that's one of the most important things about introducing AI and ML into one of these organizations, is what you're trying to do is augment the ability that you have in your domain expert and make them more valuable. You can't wander in and say, well, just show us your data and we'll make sense of it. Because any good statistician could have done that 50 years ago and found interesting pieces of the data. It's bringing that domain expert in there and saying, oh, here's where this machine broke down. And this person can say, oh, well, I know something interesting that was happening during that time or during the time running up to that point. And those domain experts are the ones that you have to integrate with. Now you have to bring in the data scientist and the domain expert and join them together as a team. And you have to have a data scientist that can talk to domain experts and not just talk data, because they're not interested in data.
So I want to ask you something different, go from sort of like the hardware to the connectivity. You talked about cellular. There's all this hype, another hype out there is 5G. I don't know if you have it, I don't.
No,
but
I don't.
It's out there in some very selected places. What do you think having so many nodes and so much fog out there, which we're gonna create more and more, you and us and everyone, is gonna do to cellular? Is cellular gonna actually be becoming less important, or is 5G making it more important? talk to me about that a little bit, because I have this vision that when there's so many nodes connected, so close, do I still need to hop up and down, or can I just hop from here to here to here to you?
That's a good point. Well, I think there's two parts, I guess, to my answer to that question. So one part of me just doesn't care about 5G. I'm sad that the rollout of 5G has taken has taken some of the momentum possibly out of the rollout of what's important to me, which is NB-IoT and Cat-M1. You know, I don't need, 10 gigabit downloads to my mobile device. I'm not planning on watching, 5 Netflix movies at once on my cell phone, like I could be, like would be possible. I'm more interested in having very, very low cost, very, very pervasive, low bandwidth, like 100 kilobit, kind of bandwidth to these edge devices. And, I'm just hoping that while they're, climbing up all these towers to bolt on the 5G antennas, they're bothering to carry a NB-IoT antenna with them and stick it on there too. Now, that said,
but we have 3 and 2G and 3G that we can use for this now?
We have LTE, which we can use for LTE Cat-M1. But that doesn't get us NB-IoT, which is the real prize here, the real low cost, low bandwidth guy. Okay. And that's going to require infrastructure update. And so, as I go out to my current, cellular providers and look for NB-IoT service, it's usually the kind of thing where it's advertised, but it's not quite available to me yet. And then part of that is because, I actually had a conversation with one of them, and we got pretty far down along a trial, and I had some test SIM cards and all of this, and I said, they asked, well, how many units are you rolling out? And so I made up a number, 50,000, and they said, we're not interested. Because 50,000 isn't much to a cell provider, right? But that's okay. They just sent me to their next tier down reseller, and I could get SIMs that went on their network. But I think that the place where 5G will become important is at that cloud, is at that gateway to cloud level, that fog processing level, because that's certainly the case. That once we do have lots and lots of edge nodes, and if we do manage to implement a mesh type network like you describe, eventually there's going to be a ton of data trying to get to the cloud. And it's going to have to get there wirelessly from many of these gateways, because it's easy to get AC power to a gateway in a remote location. You could even, get yourself a nice solar panel and you'll get there. But harder to get a wired internet connection to something like a valve on a pipeline in the middle of Canada somewhere. You could get AC power there. There probably is already, decent AC or DC power there just to run the valve, but there's not likely to be a wired Ethernet. So I need cellular there, and I need it to be fast.
I'm sorry, I get what you're saying, and I just have to admit what was going through my head is when you talked about a valve on a pipe, is we're gonna all sit there and start knocking. We're gonna send sound signals to the pipe. Sorry,
exactly.
I'm totally distracted. I don't know why I got. So cellular, particularly 5G, in remote locations, not quite the protocol you're wishing for, but it's gonna help us there. And yet, for here right now in our local industrial factories, maybe not as important.
Yeah, I agree.
Let me switch topics completely. I've been sitting here, we're in a weird time with what's going on with people being sick and people being home and so forth. Are you doing okay, by the way? I didn't even ask you.
We're all doing well, thank you.
I'm glad to hear that, I'm glad to hear. You said you are sheltering in place in Philadelphia?
Pittsburgh, other side of the state.
Other side of the state. And what is it like today, right now? Just tell me.
Well, Pennsylvania has probably a third of the counties are in shelter in place, and we are one of them. We're outside of Pittsburgh, and the office has been closed for 2 weeks, and everyone's working out of their home. We have 18 employees, and we're very fortunate that we have the type of job that can work this way. And you and I are very fortunate that we have the type of job that we can work remote. And so this is a very difficult time for a lot of people. And it's going to be, I think, a very difficult time for some of our customers, and other ones will be okay. But it's we just try and do our best to support our communities that we have here. We basically only go out to go buy takeout from a restaurant to try and keep them going.
Yeah. The question I have for you is what sort of has been going through my head, and what I'm trying to figure out is how can IoT and technology help this? And I'm not talking about, video conferencing. I'm really trying to figure out what are the things that I can bring to the table, what I can measure. The simple things that came up to me were infrared cameras that measure temperature. And that's a very common thing. It's already done at many places. But I wanted to ask you, I'm sure you've thought of this, and I'm kind of curious to hear what's been going through your head around this.
So we've been thinking about many of the same things. One of the things I was on a conference call this morning with the local university here in Pennsylvania, Penn State. They're a big university. They have a local campus near our office, and we were talking about an innovation center that they are putting in place, and how can that help the local industrial companies. We're talking about machining companies and tool and die and those types of heavy industries in the Pittsburgh area. And I think that, indirect, not directly related to the virus and people's health, but it's also the ability to work remote. We just mentioned that you and I have this ability to work remote. We can pick up, we can just pick up our laptop and our camera and move somewhere else. I can pick up my laptop as long as I have a decent internet connection. I can be on conferencing with my folks and reach my source code and all of that. But how well can a industry that has machines continue working? And what would it take to get them there? Because many of these machines aren't something that a person has to stand and push a button for every time the metal stamping machine needs to stamp a piece of metal. But they're also not yet set up to be able to be run remotely and automated, and to be able to be watched over. So there still has to be someone standing nearby. And how close are we to be able to get away from that to allow that person to be remote now? And so, how many industries were this close to being able to be run remote and couldn't? And so they're shut down right now and their folks are laid off. I think that is an opportunity, not necessarily for IoT, but for industrial control. And I merged the two together because I don't accept the term.
You don't accept the term?
I don't accept it just the same way I didn't accept Net 2.0. You know what I mean? It's a name for something that already existed,
I joke about this in this form. We never called the internet of people when there were just people on there. So I don't really know why we call it the internet of things. I hope we're going to start calling it the internet sometime again, and just stop adding, the things if it's not off the people. So in any case, any closing thoughts? Anything I didn't ask you want to talk about?
Well, I think that, in addition to this, I think that the other thing that we're going to see is more asset tracking. Folks being able to increase their efficiency just by being able to find their things. And this is not just, being able to find your package coming from an online store. It's a contractor being able to locate where his 6 pickup trucks are right now and realize that he's got one near an emergency call that he's currently having. Or even that same contractor, if he's a cement contractor, knowing he's got 8 cement mixers, but he has no idea where 5 of them are, and being able to just go on a website and say, oh, that's where we left that one because that job's not quite done and they didn't tell me that. I can go pick it up and it's only 2 blocks away to get to this other job. And the efficiencies there of being able to track assets, I think, are important. We thought that this was a solved problem, quite honestly. But then several years ago, 3 different companies came to us and had us build 3 separate asset tracking applications. And we said, okay, there's something going on here. And so 2 years ago, we built an asset tracking application. That'll be something we're rolling out next, combining it with our low power sensors so that you can start to put sensors on things, sense their health out in the field. I think that that's an important part of this, of the next step here is that, how do you lower the bar so that when folks start to look at IoT projects, they're not saying, oh, this is going to be, a 6-7 figure check just to get into IoT. You want to be able to say, no, this is a 5-figure check to be able to sense vibration on that piece of machinery and tell me if it's healthy. This is not something that I have to, float a bond for as a company. It's something I could actually take a little bit of R&D money or something like that and spin up.
I gotta tease you. I've seen a batteryless computer, which basically takes battery out of the RF energy around us, and it powers Bluetooth beacons.
Yes, I have seen those folks as well at the trade show. I think that's a tremendous good idea. Energy harvesting.
It stands for early production models, which just blows my mind. So I'm very closely following them and seeing them. Yeah. Well, Ed, thank you so much for being on the show. It was great having you. I love talking to someone who is as passionate about IoT, or I'm sorry, about the internet as I am.
You and we can make this happen.
Yes,
we can get back to the internet.
Back to the internet. I love that. Back to the internet. That's it. Well, Ed, thank you so much. With this, another Coffee with Mr. IoT is coming to an end. And with that, have a great day. Goodbye.
Thanks for listening to Coffee with Mr. IoT. To subscribe or to listen to more episodes, search for Coffee with Mr. IoT in your favorite podcatcher, or find us online at deloitte.com/US/Coffee with Mr. IoT. To watch the video version of our show, go to YouTube and search Coffee with Mr. IoT.